So maybe you got down to here and you started guessing and checking. But let's go ahead and learn how to use the calculator to do this, okay? So if we go to our calculator, okay, you can see that right here is a button that has log in it. Like I said, log base 10 is the common log. So if you're looking for a logarithm base 10, you can simply say log base 10 of 17. They didn't want to put all the numbers on here because there's an infinite number of numbers and they can only put so many. So they have log base 10 and log base e. So in other words, 10 raised to the 1.230448921 is 17. And we can test that by saying 10 to the 1.2304489 is so close to 17 that we can call it 17. And for the most part, you can round to 4 decimal places, and that should get you close enough. So that's how to use the calculator. Why don't you go ahead and take a couple minutes and fill out the rest of those using the calculator, and not using the calculator, or you can check yourself on the ones like these. Okay? So take a minute and do that. So here are the answers that I got, and if you want to check your answers there, that's a good idea. Some interesting things that came up when I was doing them were reminding us of our negative exponents, right? Which negative exponents flip things over, so this is equivalent. So if this was 10 to the negative third, that equals 1 over 10 to the third, right? The reciprocal power, which would be that. The other thing that was kind of interesting is there's no way that you can get a negative number, that you can turn a positive number like 10 into a negative number like negative 26 by changing the power. You can make it really small, as in this one above it. Okay. Also, there's no way to make it 0. You can't raise, you can get it infinitely close to 0, but you cannot make something equal to 0 by raising it to a different power. This is kind of interesting too if you think about it. 10 to the negative, if this is, what do I have to raise 10 to make it equal 10 to the negative fifth? Well, it's got to be to the negative fifth. And finally, so hopefully you got pretty comfortable using that with a calculator. I think that'll be pretty easy to do later on. Okay. So here's a definition. A logarithm is an exponent. Rewrite each of the logarithms above as an exponential equation. So if I was to do that, just right below each one, I could rewrite that as an exponential equation by simply doing this. 10 to the second power equals 100. Or 10 to the third power equals 1,000. Or 10 to the first power equals 10. Okay? Why don't you go do that, and we'll check back in just a second. So here are all my answers for that last one. Okay, you can see all the things, so you might take a second and look at those. Make sure that you follow. So for example here, this would be the exponent there. You might pause and write those down and check them for a second. Anyway, here is, so a logarithm is an exponent. Okay, definition of a logarithm. Then all right, so for all values, so definition of a logarithm, right? So if b raised to some power equals a for all a greater than 0 and b greater than 0, then that's equivalent to log base b of a is that exponent. In other words, the logarithm of base b of a is the exponent you will put on b to get a. The definition of logarithm can be used to find the logarithm of bases other than 10. And we've actually already been doing that. So if we rewrite this in power form by saying 2 to the x equals 128, and then we know that 2 to the x equals, that 128 equals 2 to the 7th power, then x must equal 7. We've already been doing some of these problems, right? Similarly, 9 to the x equals 3. That's a little weird because my argument is smaller than my base, until I remember that 3 is the square root, or that is the same as 9 to the x equals 9 to the 0.5, or 1/2 power, because that's the square root, and x equals 0.5. Similarly here, this is log base 7 of 149, so we would say 7 to the x equals 1/49th, and we know that 49 is 7 squared, and it's got reciprocalized, so 7 to the x equals 7 to the -2, so x equals -2. In these examples, all the logarithms are rational numbers, and we've already been doing this, okay? We just didn't know we were doing logarithms. So let's look at this next example where it's an irrational number. Find log base 5 of 79. Well, if I know log base 5 of 25 equals 2 and log base 5 125 equals 3, I can guess that log base 5 of 79 is going to be somewhere around 2.6-ish, right? Somewhere in there, and I'm probably off a little bit. But using the definition of a logarithm can be written as an exponential equation. So I know that 5 to the x power equals 79. And then I can start to think about how to solve that problem. One way to solve this equation is to rewrite 5 and rewrite 79 as a power base 10. So then you're going to kind of guess and check around a little bit to find those. So let's pause for a second. So let's think about this on the calculator. So I need to find out what 5 is as a base 10, and what 7 is, and what 79 is as a base 10. So I'm going to go into my calculator. I'm going to go into my calculator, and I'm going to say log of 5. Well, so that's 6.98. Let's see, 6.987. Okay. So I'm going to go back to my problem here, and I'm going to say 0.69899.7. Okay. And go back into my calculator and say find the log of 79, and I'm going to get 1.8976. 1.8976. Okay? Now that seems kind of wacky, but let's think about this for a second. If I've got 10 to the 0.698957 equals 10 to the x, right? Then that equals 10 to the 1.8976, right? Now, if I know this is true, right? So if the bases are equal, so the exponents must be equal. So 0.698937x must equal 1.8976. Divide by that number, and I'm going to get a number. Let's see what that is. So I go into my calculator once again, and I'm going to take this number, and I'm going to divide it by 0.69897, and I'm going to get 2.75 approximately. So let's go back in there. So 2.75 approximately. Okay. Does this answer check? Let's see. So 5, remember we're going back up here and we're saying 5 to this power 2.75 should equal 79. So 5 to the 2.75, and there's going to be some rounding error, obviously, equals that number, which isn't really close to 79, is it? Did I round up?